didn't have to do it in this. I just did it for an hour.
Get something better.
So yeah. Devastated. There was no point. I'm actually Hey!
You don't leave a mask. I didn't finish it though. It's not really
I am on time.
Whoa, whoa.
Both.
I'm he golfing.
Right. No, Elian. Okay, I know you think I'm better now.
Test in 2 days, guys. Ready to fill the class?
Yeah.
Woo!
Yeah, buddy.
If you sacrifice, go with the teacher. That's right. That's what happens in all the class.
When you come in, we're gonna keep practicing this until we get it down. In your seats. You got a math review. Or you lost your glasses. One should be pretty straightforward. Two, you need to turn the numerator into a fraction and the denominator into a fraction. Turn this into a fraction, turn that into a fraction, and then simplify it. So take 5 minutes, get that done, and let me know if you need a pointer along the way. Happy to help you out. So, while you're working through them, maybe you can just shout them out. What's the vertical asymptote?
1/3.
Not just 1/3. X equals 1/3, right? Horizontal asymptote? Not just -5.
Y equals
There we go. What's another quick one to find?
y-intercept.
Y-intercept, that's pretty quick.
-7.
When x is 0, y is -7, yep. What's the next one we should probably find? X-intercept? Well, let's see, if you set it to 0, let's just walk through that one. 0 equals 2 over 3x minus 1 minus 5, add 5. Multiplied by the denominator to clear it. You can multiply out, but that would waste your time. So divide by 5. Add 1. 2/5 plus 1, well 1 is 5 over 5, so 7/5. I need to clear a positive 3, so I multiply by a 1/3. Multiplied by 1/3 to cancel. So x equals 7 over 15. That you got? Okay. You write it as a point. X-intercept 7/15, comma 0. And domain and range. Oops. Domain. Well, let's see. X is such that x cannot equal. You guys fill in the blank. There we go. 1/3. Range. Y is such that y cannot equal -5. There you go. So give me a thumbs up if you're good with that one. Okay, if not, you need to check out those videos because we got an assessment. This skill is a prime suspect on there. All right. Number 2. Number 2. Does anybody have the algebra down and want to get their presentation out of the way to show us how to do this one? We're going to start running out of days here for the people who haven't come up yet. All right, need to turn this into. Yeah, we're going to turn it into, but before we even go there, turn these into fractions. Turn these into fractions. This is 5 over x plus 2 minus 3 times x plus 2 over x plus 2. I created a fraction out of this, right? I multiplied by the least common denominator, right? My special 1 that I multiplied was x plus 2 over x plus 2. You see that? I created a fraction. So I could add these two. Down here, 17 over 2x minus 1, plus, I turn this into what? Over. Why did I do that? If you guys don't understand that step, you really need to get that down right now. So ask a question if you don't understand that step.
Oh, because the 1 into 2x minus 1.
Yeah, the 1 is this. That divided by itself is 1. We did that so we can add these two. We did this so we can add these two. So ask a question if you don't understand that step. Okay? And you all understand. Alright, well then let's combine like terms up here. This is 5 minus 3 times x, 3x. 3 times 2 is 6, but it's being subtracted, so subtract it. That's all over, x plus 2. Well, let's see, 17 plus 2x minus 1. 17 plus negative 1 is 16. So you get 2x plus 16 over 2x minus 1. Now it looks like something we can do, right? Looks a lot easier. Well, actually, let's fix this guy up top, too. This is what? Negative 3x, 5 minus 6, negative 1. So this is negative 3x minus 1. Negative 3x minus 1 over x plus 2 multiplied by the reciprocal of this one times 2x minus 1 over 2x plus 16. Is anything going to cancel? No. This doesn't have a pair. This doesn't have a pair. There's no way to cancel anything. So your final answer you would just write like this in factored form. Right? This is all one fraction. This times this is in the numerator. This times this is in the denominator. So you need to ask a question if you're stuck on this one, yeah?
What would just like, so like x plus 2 with parentheses around, what would just like one of those be called?
This one?
Yeah, just like factored something.
The x plus 2 over x plus 2?
No, because like, in the last one, like each one of those has parentheses around it, or just like one thing with parentheses around it.
Sure, this is a term, or this is a binomial, right? This, if you want to look at these as factored terms, right? This is a factored term, this is a factored term, this is a factored term, this is a factored term. And this is also all in the denominator, all in the numerator. Okay, Molly?
Would it work if like at the start you didn't like separate the top two, but like you started like you simplified completely the top and then the bottom and then combine them? So if you like multiplied like negative 3 by, or you multiplied all by x plus 2.
Multiplied the top, everything by x plus 2?
Yeah.
Well, you can't just go around, if you're saying to do this, is that what you're saying?
Yeah.
Now careful, because what did you just do to this original expression? You multiplied it by?
X plus 2.
Okay, but then compared to over here, what did you do to this original expression? You just took negative 3 and you multiplied it by?
1.
1. Do you see how this one doesn't change anything?
Yeah.
Do you see how this one would change something?
Yeah.
Okay.
Wouldn't it get rid of the x plus 2?
It would. You're right, but I just want you to point out, you just manipulated this expression. So you just turned it into something it wasn't. It's now x plus 2 times bigger than what it was before. Does that make sense?
Yeah.
Yeah, because it's a really good question. This one did nothing. It was maybe fancy manipulation, right? We didn't do anything. This one, you manipulated it, but you changed it. Okay, that's a really good thing to note. Do you see that? Okay, so good questions. Keep them coming. Did I answer your question?
Yeah, sort of.
Yeah, so you cannot do that. You cannot do that. If the only thing you could do is if you multiplied it by x plus 2 over x plus 2. But then that would make this bottom piece more messy. Yeah, because this is 1. Good to go on? Good. Okay. So objective, we're still in 8.5. We did equations yesterday, and now we're going to do inequalities today. So we did equal signs yesterday. Today we do inequalities. No, that's it. So yesterday we worked with equal signs. Today we work with these, which kind of look like faces. All right. So here's where we're going to start. Solving a word problem. So let's get Toria. Would you read this one out for us?
Natalie can finish a 500-piece puzzle in 8 hours. When Natalie and Renzo work together, they can finish the 500-piece puzzle in about 4.5 hours. But how long will it take Renzo to finish the 500-piece puzzle if he works by himself?
Okay, thank you. Let's start off by all getting on the same page. What's our end answer going to look like? Number of hours, right? How much time for Renzo to finish a project by himself? You don't need to copy this whole paragraph down. You just need to pull out the important information. So, Natalie, how long does it take her to finish one puzzle?
Yeah.
So her rate is one puzzle per 8 hours, correct? One puzzle per 8 hours. What about for Lorenzo? One puzzle per question mark or X hours, right? We don't know. We don't know how much time it takes. That's what we're going to find out. Let's start filling in things that we know. We have their rate, so we took care of that. We took care of Renzo's. Oh, now they're talking about working together. If they work together, how long does it take them to complete one puzzle together? 4.5 hours, 4.5 hours. So, would you agree that if I add the work they did, their rate, plus their rate, that would equal one puzzle divided by 4.5? Let's write it down and see if it makes sense. Natalie's, she does 1/8 of it. Renzo's, he does 1/x of it. Together, they do one puzzle divided by 4.5 hours. Make sense? Okay. Now, there's different ways you can solve this. You can multiply by 4.5 to clear the denominator. You could turn this into a fraction, one fraction. There's different ways to solve it. Do you want to try on your own solving it for a second? Okay. If not, I'm going to give people about a minute to try it. I suggest you do the same, and then I'll go through it. Let's see if you can solve that for X. See if you can. Here's another way. I didn't think about this one earlier. And then it'd be pretty quick to solve for X. .5 is 9/2. That's going to make my problem easier. Two 9s minus 1/8. Let's see. What is that? Common denominator. What would be the lowest one? Or just pick one. 72. 2/9 turn it into something over 72. I times the bottom by 8, so I times the top by 8. So that's 16/72. 1/8, turn it into something over 72. Well, let's see. I times 8 by what to get to 72? So I times the top by 9. 1 over x equals 16 minus 9 is 7. 7 over 72. So you can multiply, cross multiply and solve, or you can just say x should be 72 over 7. But let's just do the cross multiplying and solve. 1 times 72 equals 7 times x. Divide by 7. X equals 72 over 7. That was pretty quick, right? Yep. Notice how fractions sometimes make your life easier. All right? I can combine these things very easy, and when things are like this, it starts getting messy. So know how to work with fractions. Do you have any questions about that process? Yeah, Brandon?
Could you put it in the form of a decimal?
No, it would not be exact. Like this is exact. You got 10 point, so that's about 10.28 hours. I would not mark you down for that, but I want you to, throughout this year, start getting better at working with fractions. So this would be fine, but throughout the year, keep working on the fractions. Any questions about this one? Anybody solve it a different way? Multiple ways to solve it. Okay. I didn't hear any questions, so I'm going to move on. This is one of the most, I guess, I don't know, they're one of the most fun problems in my mind. So why don't we get somebody to read it? Why don't we get somebody to read it? Thanks, Calvin.
On a river, a kayaker travels 2 miles upstream and 2 miles downstream in a total of 5 hours. In still water, the kayaker can travel at an average speed of 2 miles per hour. Based on this information, what is the average speed of the current of the river? Round to the nearest town.
Okay. Thanks, Calvin. All right, so let's all just start off from the same page. What are we trying to get to?
Average speed.
Average speed of the current. Draw yourself a picture for a minute of what this problem is saying. Draw yourself a picture of everything you know. Doesn't have to be right, but draw yourself a picture because that's helpful. Very helpful for this problem. Everything you know, draw a picture. And that's why it's fun, because you get a draw for these problems. All right, so there's the person in their canoe. That's one piece of information. And they're going 2 miles upstream. They're also coming downstream 2 miles. What else am I missing? 5 hours, total time. Time total is equal to 5 hours. Does that mean that it took them 2.5 going this way and 2.5 going that way? No, right? And that's what makes this problem hard. All right, so let's see. There's something else I didn't put down. Still water speed is what? 2 miles per hour. Did they go? What direction did they go faster in if I tell you that the current goes this way? This way they went faster, right? How? Because of the current, right? Well, the current, just call it C. How fast did they go going this way? There you go. 2 plus C miles per hour, right? How fast did they go coming back? 2 minus C. I'll put that down, miles per hour, so it's clear. So just take a look at this picture and make sure that everything makes sense to you. You have a question about anything?
Why is that on 2 minus C, not just 2?
because that's in still water, but when he was coming back, he was fighting the current. So they went 2 minus e miles per hour. 2 miles per hour is in still water. But this wasn't still water, they were fighting a current.
Wasn't there current up and downstream?
No, there's currents only flow one direction, right? So he goes fast this way. And then when he comes back, he's fighting the current. So it's going to be harder. Okay? All right? So if we write down what we know, all right, totals, time total is equal to 5 hours. I also know distance total is equal to 4 miles. Maybe that's helpful, maybe not. Let's see what else. There's something that they didn't tell us, which gives you a hint as to what you want. They didn't tell you how long it took for both directions, right? So that's a key, that's a kind of a guide to what you want. They didn't tell me what time 1 is. They didn't tell me what time 2 is. So maybe I should find those out. If you remember dirt, all right, then you can do this problem, right? T is equal to D divided by R. So now tell me what time 1 and time 2 is using this fact. So give me an expression for time 1.
Divided by 2 minus c.
2 divided by 2 minus c. Distance divided by rate. Other one. There you go. You have time 1 and time 2. You add them together, what are you going to get? Time total. So set up that equation. All right, you add these together, you're going to get that. You have a 1 variable equation, and then you can solve it, right? Okay. So set it up, and let's solve. Two over 2 minus c plus 2 over 2 plus c. That's equal to 5. Good with that setup. Multiply everything by, that's the one special factor I can multiply. Might involve multiple terms that I can multiply by to cancel all these fractions. Yeah, multiply everything by 2 minus c, 2 plus c. And you'll see why it cancels stuff in a minute. I multiplied everything by that, so this is 5 times 2 minus c, 2 plus c. And then you can probably solve it from here, so keep trying on your own, but I'll walk you through it too, if you don't know how. Oh, there's a 5 right there.
Oh,
Yep. Cancel the 2 minus c's. Cancel the 2 plus c. 2 times 2 plus c, so that's 4 plus 2c. Plus 2 times 2 minus c, so that's 4 minus 2c. That just comes from evaluating and simplifying the numerators. Should probably multiply this guy out first because it's 2. 2 times 2, 4. 2 times c, positive 2c. Negative c times 2 is negative 2c. Negative c times c, negative c squared. That was all being times by 5. So you see something nice happens? No more c's right there, right? You don't see any more c's. 5 times 4 is 20. 5 times negative c squared is negative 5c squared. And let's simplify this side. 2c and negative 2c cancel. 4 and 4 is 8. All Alright? Now solve. Add the 5c squared, subtract the 8. Add 5c squared. Subtract the 8. And let's see, divide by 5 and take the square root, right? Divide by 5, take the square root. So look at all those steps and tell me if there's anywhere where you're having trouble. You're sleeping, maybe you're tired, didn't catch something. Let me know. Happy to help. Okay? T?
So when you put the, like when you're going to like multiply everything that you can cancel the denominators,
Mm-hmm.
like how do you know to do 2 times 2 minus 2 times 2?
Because the least common denominator here is just this times this. So the least common denominator is 2 minus c times 2 plus c. And so therefore, if I multiply by always the least common denominator, it will cancel all those things.
So you times the 2 times the least common denominator?
Yes.
Okay.
Yep. So that's one way to find a nice denominator to multiply by. So is there another question for the steps of this one?
Wait, so you also multiplied 5 on the side.
I did. What you do to one side, you also have to do to the other side. Another question on this one?
Can you explain what you did, like, where you have the plus 5c squared on both sides?
I added 5c squared so it wouldn't be negative.
Yeah.
So I added 5c squared to both sides. I subtracted 8 to get 20 minus 8 is 12. Yep. There's something else. Here's your answer. Plus or minus square root of 12 fifths. Does that sound right?
No, because you can't have a negative.
You can't have a negative. Why? Because what does c represent?
The current calculation.
Current. So there's only one answer. Positive square root of 12 fifths. And you should probably say what it's talking about. Miles per hour. Yeah, that's fine too. Yep. This is exact. The decimal would be approximate. So, good with this? Word problems fun? You're gonna be grateful that you get so much experience with the word problems. Trust me. They're hard at first, but the more experience you have, the easier it gets. So it's hard at first. I'll give you that. It's totally true. We have to do one more thing today, and this is the hardest part of 8.5, so you need to get good notes on this, because this is something we haven't done before. It's called solving rational inequalities. Yeah. And to simplify it, bullet point 1 says essentially eliminate denominator. So it says clear the fractions. Step 2 says there are 2 cases you need to consider. So if you want to simplify your writing, that's all this is saying. Clear denominators, 2 cases you need to consider. There's some new notation that you need to get down too. So if you're sleeping on me, you might want to go get some water. Wake up. There's 2 cases, which means you're probably going to get 2 different sets of solutions. So you see this U here? This means or. So it's either going to be that x is less than something, or x is greater than something. That's going to be your complete solution set. So this reads, set of x's such that x is less than a, or x is greater than or equal to b. This is just one of 4 examples, right? These are different solution sets. You can see there are different combinations. So we know what union means. That big U means or. It means union, it means or. Either or. And here's a good math thing. If I tell you something's or, could it be both?
Yes.
Yes, it can. So be careful. Or means either or possibly both. All right. Do we have this page down? All right, so I'll give you another minute to copy it down because I want to make sure we get through this. The big idea is make sure you know those 2 easy steps. Eliminate denominators, look at 2 cases, and then know what union means. Union means or.
These are not the only notations.
Say it again.
These are not the only notations.
Right, there's plenty of other ones. Could be possible that you don't have any union. Could be possible that you only have that piece. Could be possible that it is both pieces, so in that case we would do the and. So different ways. These are just some samples. Okay, so here's the one thing we need to finish solving for today. So copy it down. I want to say something real quick before we start. Make 2 separate columns because we have to look at 2 cases. Right? For the same problem, 2 columns. X minus 8 is a number, right?
Yes.
It's a number. It could either be positive or, so what are our 2 cases? Our 2 cases are x minus 8 is positive. Our second case is x minus 8 is negative. And this is the fun part of math. So if you like logical reasoning, you like math, you probably like this piece.
What if it equals 0?
It cannot equal 0 because division by 0 is excluded. Can't do that, right? But it's a good thought. I'm glad you're thinking about that possibility. This covers all the cases. X minus 8 is positive, x minus 8 is negative. There's a more precise mathematical way of saying something's positive. If this is positive, what does x minus 8 have to be?
Greater than 0.
Greater than 0. If this is negative, x minus 8 has to be
Less than 0.
less than 0. Let's just also simplify that before we even get started. What does that also imply about x? X has to be,
Greater than
x has to be,
8. Less
all right, so these are 2 different cases. And we have all the groundwork, and now we can start solving. The reason why you have to consider 2 cases is because if you have 5 divided by x less than 2, if you multiply by x to get rid of the denominator, does anything happen to the sign if x is positive? No. But if you have 5 divided by x less than 2 and x is negative, what happens when you multiply by x?
Flip the signs.
And that's why we have to consider 2 cases. All right? So that would change the sign, and that's why we have to consider 2 cases. So that's what we're going to do here. Let's start with this one then, because this is quick. You know how to solve this. 6 divided by x minus 8 when x minus 8 is positive. Well, just multiply both sides by x minus 8. 6 less than or equal to 3 times x minus 8. You can distribute that 3, but you'd waste your time. You should divide by 3. Divide by 3. 6 divided by 3 is 2. 2 is less than or equal to x minus 8. Add 8. 10 is less than or equal to x. So you're good with this column? You're not done yet, though. look at these two different statements here. So what I mean when I say look at it, look at it. X is greater than 8. X is greater than or equal to 10. Those are two different statements. One satisfies both of those. There's one statement that'll satisfy both of those, and you can only pick one. So which one satisfies both x greater than or equal to 10 and x greater than 8? Why does this one work?
Because the number's big.
Sure, it's bigger. If I pick 11, is that going to be greater than 8?
Yeah.
If I pick 9, is that going to be greater than 10? This is the only one that satisfies both. I'll repeat that. If you pick 9, that satisfies this, but not this. If you pick 11, 11 satisfies this and this. It needs to satisfy both, therefore you pick this one.
So anything from 10 and higher.
Yes, you can pick 10 and beyond. Okay. That's this left-hand side. And now we have to deal when x minus 8 is negative. It's the same process, so let's set it up. 6 divided by x minus 8, less than or equal to 3. But now what happens when I multiply by the denominator? Yes. So I would star this step right here. The sign is going to flip. 6 is greater than or equal to 3 times x minus 8. Again, you could distribute the 3, but that'd be a waste of time. You should divide by 3. Six divided by 3 is 2. 2 is greater than or equal to x minus 8. Add 8. 10 is greater than or equal to x. So you think you're done, right? But you're not, because you need to go back and relate it to. So you kind of create like a loop, right? I need to go back and say, what happens here? X is less than 8. X is less than or equal to 10. Which one should you pick? You got it. You should pick the smallest one, right? Because if you pick 9, it'll satisfy this, right? But it won't satisfy that. Okay, so pick the minimum of the two. You pick this one. And now you are done after you write your solution set like I showed you a second ago. X is such that, give me the two different pieces. Give me the two different solutions. X greater than or equal to 10. Union. X is less than 8. So there are two different set of numbers that will satisfy this equation. Negative infinity up to but not including 8. And then you can go from 10 all the way up to positive infinity. Anything in those two pieces would satisfy this original equation, inequality. Does that make sense? I think Aiden had a question. Let me.
So when does the thing flip?
It flips when you multiply by a negative. And it would, you can't see any negative signs here, but I told you that x minus 8 is negative. So that's when you have to be careful. Okay?
So why is it x is smaller than 8 instead of is greater than x?
Say it again?
So why are you choosing the top one or the bottom one on the right side?
Top one?
Yeah, why are you choosing that?
Both of these things need to be satisfied. If you pick x less than 10, give me a number that's less than 10 but in between 8 and 10. So give me 9, right? Does 9 satisfy this? 9 less than or equal to 10? Yes. Does 9 satisfy this? No. That's why you have to pick the one that satisfies both. Yep.
So like you always choose like the x plus or minus whatever number one for you?
Well, we didn't pick that one down here.
No, I meant like actually.
You sure? Okay. You just need to analyze it and say which one satisfies both. Right. Okay. I guess one last thing I want to tell you before you leave today is that if you want to check your solutions, draw a number line. If I was going to draw a number line, what 2 points should I mark down? 10 and 8. 8, 10. I said that everything over here is going to work. I said everything including 10 in this way is going to work. So if I want to check my work, I should check a point here, I should check a point here, and I should check a point here. If I check a point over here, do you think this should be true?
Yeah.
Should be true here. Should be what here?
False.
False here, and it should be. That's a good way to check your work. I know there's a lot today, but how many of you like this logical way of thinking? Yeah. Well, I do too. All right. If you didn't take the CFU yesterday, take it today. Because some of you didn't take it.
So do you just use when there's like a gap?
Yeah. When there's a gap, you want to use that